Okay, this problem is very important problem that I am discussing today. Okay, right. So show that B union intersection I tends to 1 to n ai equals intersection I tends to 1 to n B union ai. This is what we have to prove that. So what you are seeing here, B union intersection I tends to 1 to n ai must be equal to intersection I tends to 1 to n B union ai. That's what the problem about. Now how we are proving this? Now let us take this now. Let P of n is equal to B union inside the bracket intersection I tends to 1 to n ai equals the given statement. That is the given statement we are taking as P of n here. So you will have here intersection I tends to 1 to n B union ai. Okay, so as it is we are taking there. For n is equal to 1 and 2, this is true. Why? Look at this. B union for n is equal to 2, B union a1 intersection a2, which is equal to from the distributive law B union a1 intersection B union a2. This is what distributive law. By distributive law we can get this. Okay, so for 1 and 2 this is true. What about for other n? Okay, so now we are assuming that let, okay, that's what we have, let P of n holds for some m belongs to n, but some is for some positive number m which equals n. This therefore what we have here is that B union intersection I tends to 1 to n ai is equal to intersection I tends to 1 to m B union ai, because for m is equal to n this given P of n is true. That's what we are assuming there. Therefore we have this particular statement is true, we are accepting. Okay, now how can we write this? Now suppose for m it is true, then B union intersection I tends to 1 to m plus 1. So instead of m we are writing m plus 1 ai, and that is equal to B union intersection I is equal to 1 to m ai intersection a m plus 1. From this step we get this step. Okay, right. From this step we get this step by using distributive law. Okay, so this B union, this coming out, intersection I tends to 1 to m ai, then intersection, this intersection comes here, then this and this, B union a m plus 1. Okay, now using P of 2 for sets intersection I tends to 1 to n ai and a m plus 1, what we have here is that that particular idea we are using there. Therefore this will come out, B will go inside union of ai intersection. Okay, that intersection we are bringing inside, as it is previously we are getting this particular step here. For this step only we are using this particular idea. For P is equal to 2 it is true, and we are assuming that for n it is equal to true. Therefore we assume that for m also it is true. So we are bringing that intersection outside. We have B union ai, B union ai, that's what we have there. Okay, now we look at this and we are getting this particular step. Now what we have here is that intersection I tends to 1 to m B union ai and intersection B union a m plus 1. So bring this m plus 1 this side and add with this one, you will have intersection I tends to 1 to B union ai, and thus we can prove the this particular fact. This is the way we can prove our theorem there. Okay, so thank you very much.